Hello everyone, I am Anil Kataria. I am here to give presentation on surface modification of titanium alloy, which is a part of my engineering research methods. And as a research question, I have evolution to biocorrosion and bioactivity of sol gel derived substrate. Objective of this presentation is to define basic concept and the definition of bioimplants, surface modification techniques, and explain experimental design. A biomaterial or a bioimplant defined is a substance, it is a substance or a combination substance which other than drugs. That means the uh, origin of synthetic and natural lifespan generally 20 years, but it is depends on where you are using this implant, because if you are using this orthopedic 20 years, it's generally there is no standard for this one, and it should be augment replace any tissue organ or any part of body. Biomaterials, generally biomaterials are metals and their alloys like titanium alloys, stainless steels, cobalt, chromium, etc. And then ceramics for polymer, carbon composite, etc. are the materials which is used as a biomaterials. And here is some example of hip replacement of biomaterial. So this is another example in which I have show you that this is the real time example, like this is a real body part which is replaced by the orthopedic implants. This is a hip implant and this is a knee implant which looks like this one, similar. Biomaterials generally classified in three manner. It's a first generation, second generation, and the third generation. In first generation, it comes the bio inert materials. Second generation, bioactive and biodegradable materials. Third generation is the material design simulated specific response at the molecular level, which is a very high level of replacement, like a heart replacement or heart valve replacement. Ideal biomaterial should be non-toxic, good corrosion resistance, great strength, absolutely corrosion proof, low elastic modulus, and inexpensive. I would rather say relatively inexpensive, because every biomaterials are not economical, but still we have to consider as a relative inexpensive materials. Mostly titanium and their alloys are using as a biomaterial, bio implant. Here is an example of the commonly used titanium alloys, Ti6Al4V. Here is a composition of titanium 89, aluminum 6, vanadium 4, and others 1%. This is a standard alloys which is often used in orthopedic implants, like bone replacement, joint replacement. As earlier I show you the photographs which is made, which is replaced by the orthopedic implant. It is made from the same alloy, and I am also going to use this alloy for my experimental. Okay, once bio implanted in the body, this should be response like this. Two response would be possible, like toxic and the non-toxic. If it is toxic, then the death of surrounding tissue, that means it is an adverse effect and it will not help patient or their life or their body. It will only have adverse effect which is ruin their life, their body, and their surrounding tissues. And the non-toxic, on the 99% cases we achieve the non-toxic cases, which derived in three: biodegradable, bioactive, bioinert. Now, due to corrosion or some other chemical reactions, the non-toxic materials there are chances of becoming toxic, which can hurt or which can have adverse effect on the human body. These are some examples that elements we are using as a bioimplant, like nickel, cobalt, chromium, aluminum, and vanadium. As earlier I show you the titanium alloy, in which we have the aluminum and vanadium. Vanadium is very toxic when it is in elementary level. However, we are not using vanadium and elementary level in this alloy, but due to corrosion there are chances that vanadium may become on the elementary level, and it will hazard, or it will have adverse effect on the body implant. Same way, aluminum aluminum also can be just spread the disease like Alzheimer's and etc. So these are the elements which is frequently used in the material, and they have some adverse effect on the body of human. So to remove this, we have the surface modifications methods. Surface modification methods generally improves the quality of implantations. They makes life easier. They enhance the life of material. They enhance the life of replacement, and they also improve the osteogeneous process, everything. So we have three major methods, can be like mechanical, chemical, and physical. In mechanical, we have grinding, polishing, machining, and blasting, which is used for the change the surface topography and make surface rough or good polish. It depends upon requirement. We have the attriation, which is very useful when it comes to the nano level. The second method is physical method. We have so many methods in the physical, like thermal spray, flame spray, plasma spray, high velocity, etc., which is always used to improve wear resistance, corrosion resistance, and biological property. The third one and most important is the chemical methods. Sorry, chemical methods are generally used for remove oxidized scale, improve biocompatibility, bioactivity, or bond regeneration. There are several methods which is used as a chemical methods, but here I am going to explain something about sol gel methods. Sol gel methods it is used for improve biocompatibility, bioactivity, or bond conductivity. As I earlier explained that my research question is to improve the bioconductivity and the biocorrosion, so which is suitable for in sol gel. So in this experiment, I am going to use the sol gel methods. Here, this is my experimental design in which I have used polychloride and chloroform as inorganic materials, and butane, butoxide, ethylenic acid, and water as organic materials. I mixed these two and made a inorganic organic bath at a room temperature. I stirred this one, and on a simultaneously I cleaned the surface of titanium with the ultrasonic treatment in acetone for 30 minutes. Then I moved this to the passivation in the nitric acid for 60 minutes, and for the 60 minutes after that, after 24 hours, I did this for 25 to 10 mm per minute, and then heat treatment for 45 minutes to stabilize the film, which is achieved by this method. So this is my research design. And advantage of design is it's provide good control on the parameter to achieve nanostructure on the surface. Thickness of coating can be controlled as the surface coated by layer process. In this process, I am going to use the layer by layer process, which you can control the thickness of the material. So this is how it is advantageous. The only disadvantage I reckon is this time consuming, a very long process, and it consumes more time than other designs, but it provides good result. If you have any question, please please mail me on this my email address. You can contact me. Yes. Thank you.